This is our yellow assignment number 4. The story says the equation y equals 3.25x can be used to determine the number of cups of flour needed to bake x loaves of bread. Which table shows the relationship between x and y? So apparently for 1 loaf of bread, you need 3.25 cups. So the more loaves of bread you want to make, the more groups of 3.25 cups of flour you would need. So they've written it as a rule that every time you change how many loaves you want, you're also going to be changing how many cups of flour. We're supposed to find which table shows this relationship, this times 3.25 relationship. First of all, if I multiply whole numbers by about 3, will the numbers be smaller when I'm finished, or will they get bigger? 3 times a whole number will make the result bigger. So the first thing I want to do is make sure all these tables are going from smaller to bigger. And they all are. So I can't get rid of any just yet. The next thing I might want to do is look at where the tables are the same and where they're different. For example, this table says 2 loaves will be 6.25, and this table says 2 loaves will be 6.5. So they both can't be good tables. So maybe one thing we would want to check is what really happens when you multiply 3.25 times 2. Let's check and see which of these, if either of these, is true. 3.25 times 2, I'm just going to come over here on the side of the paper and multiply. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6. But 3 times 2 should be about 6, not about 650. So put a decimal point back in the product. 650, not 625. So if there's a problem in one part of the table, the whole table is not a good choice. We're going to just get rid of C right now. We have decided 6 and 5/10 is good. So I'm going to put a check. We've checked that pair. It's good. What else is the same? Oh, on A and B we have 3 here and 3 here. Well, if 2 groups of 325 is 650, then there's no way that 3 groups would be less than that. So without even doing any work, I can see that one makes no sense. So that goes goodbye A. I'm not saying this is true. I'm just saying there's no way that one is true. So maybe the next thing we want to check is this 3. Putting it in for x, 3.25 times 3. $9.75, that looks true. These two are exactly the same, 6 related to 19.5, so I don't think we need to check those if they agree. 8 and 9 are different, 12 and 13 are different. So likely these are correct because they're the same. So let's look at 8 groups. If we wanted 8 loaves of bread, we'd multiply 3.25 times 8. That looks good. Last of all, we have 12. 3.25 times 12. Let's try it. Two times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. Done with those. We're going to put a 0 because this is 10 times more. And then 1 times 5 is 5. 1 times 2 is 2. 1 times 3 is 3. Adding that all together. Looks like 3,900, but 3 times 12 is about 36, so this is 39. Put the decimal point where it belongs. So did we find a table where every pair of numbers follows the rule? We did. I'm going to go with B. Actually follows the rule. I can tell this doesn't follow the rule because 9 times 3 is 27. So 9 times 3.25 would be more than 27. So that's wrong right there. If I would have noticed that first, I could have saved myself the trouble of multiplying the 3-digit by 2-digit. Oh well. Learn more every day. So this is a little experience with looking at additive and multiplicative relationships in tables and using our variables x and y in order to create what will become ordered pairs on the graph. Now that we know this is a good set of ordered pairs, we could go across 3 up to 9.75, put a dot. Across 6 up to 19.5, put a dot. Across 8 up 26 and put a dot. Across 12 up 39, put a dot. We would be able to graph this rule, y equals 3.25x, by putting those ordered pairs on the graph. So that's what we'll get to do next week. For today, you're going to make sure your name is on your paper. Right where it says name, put your name. You're going to turn this into your teacher so you get credit for participating in today's lesson.